Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on firing circuits for SCR, that means Thyristor. So now here SCR having three terminals, anode, cathode and gate. So here if you give the positive supply to the anode and negative supply to the cathode, the SCR is in forward blocking mode condition. So now here to conduct the SCR should be in the forward conducting mode, but it is in the forward blocking mode. So to turn on the SCR, so the SCR is in forward conducting mode means there are different methods, turning on methods. First one is the gate triggering method, and next second one is a forward break over voltage, and next third one is a dV by dt method, and next fourth one is the lighting method, and next fifth one is a triggering method. Among all these turning on methods, triggering method, so gate firing circuit is the most reliable and efficient method in this gate one. Now here conditions for triggering or firing circuits for SCR. So now here, so gate current should be sufficient amplitude, means that magnitude, means that peak value must be sufficient, that should flow in the circuit for required duration. So now if it is required duration, means if it is continuous gate current, so now there will be a power loss. So now if it is flows in discontinuous mode, means it required in the required duration, then only power loss will be reduced at the gate terminal. And next here voltage pulses should be fed to the gate drive first, then after give it to the gate cathode. So now here first this is a gate. So now here first your gate pulses should be given to the driver circuit. After that it will be given to the gate cathode circuit. Now if suppose there are n number of SCRs, so now here, so for each SCR, so here we need here there are more than one SCR, means n number of 2, 3, 4, and gate current for each thyristor must be provided at desired instant of time. So here gate current for each thyristor must be, so here different individual gate driving circuits are required. So now here what are the features? So first feature is the firing circuit should produce triggering pulses for the thyristor at appropriate time instant. So there needs to be a electrical isolation between firing circuit and thyristor. So this we will attain in the UJT firing circuit, and this it is achieved by using pulse amplifier. So now here we have three types of firing circuit. First one is the R thyristor, next second one is the RC resistance firing circuit, and second one is the RC circuit, resistance capacitance circuit, firing circuit of SCR, and next UJT, unijunction transistor. So now here first R circuit. So now here in the R circuit, so how it will be conduct, means how we are giving IG current to this SCR. So this is anode and this one is a cathode. Anode, this one is a cathode, this is the AC supply. So now here give the positive supply. So here give positive half cycle during positive half cycle. So during this positive half cycle, so now here give the supply to this SCR. So now what will happen? So now here initially during positive half cycle, so the thyristor is in forward blocking mode. So when you give positive terminal of the battery is connected to the anode and negative terminal of the battery is connected to the cathode. Sorry, that is the case for battery. So here we are giving positive supply, means here this is in forward blocking mode. So here we are not giving gate current. So now when it will be a forward conducting mode, when you give the gate current only, then only gate current flows, and this thyristor is in the forward conducting mode. So now here this is the setup for R firing circuit. So now here this is a R1 resistance, that is limiting resistance, and next R2 is a variable resistance, one diode I am giving, and next R. So now here when you give the, now here during positive off cycle, this is in forward blocking mode. So now here, so here it requires minimum gate current. So here, so to turn on this one, so Ig equals to 0 initially in the forward blocking mode. So it requires minimum gate current. So minimum gate current. So it requires minimum gate current. So then only this SCR will be, J1, J2, J3 junctions will be in forward bias, and forward this SCR is in forward conducting mode. So here what it will do, next R1. So what do you mean? This is the limiting resistance between anode and gate. Anode and gate. This is the gate, and that limits the gate current should not exceed peak maximum gate current. So it requires minimum gate current. So but here this R1, what is the main purpose of this limiting resistance R1 is, it is in between these two, anode and gate. So here maximum gate current. So maximum gate current, so it will set up, so it limits that, so it should not exceed that maximum value. This R1 value will determine. So now R1 value is used to limit the gate current to its maximum value, not this minimum value. And this limits the current flow into the gate terminal, its value such that the gate current should not exceed the maximum gate current. So here if you have minimum gate current only, it will trigger. So but it decides the maximum, so that I maximum equals to R minimum. So this R1 is equals to VG gate voltage divided by maximum gate current. Now here what is the purpose of this one? So now this will determine Ig maximum. So it will ensure that one is, that should be maximum. And next, what about this one? So it will decides, so firing angle and output voltage V0, and this is Vs output voltage, and this firing angle alpha can be determined by varying this R2 resistance. So if R2 value is large and current will be small, and hence firing angle will be alpha is the large, and same way R is less and current is high and alpha will be less. So now this is the relation. So when gate current is applied by the resistance R2 such that the current should be more than minimum value of gate current, the SCR should be on. So now here, so it is, suppose it is at 0 position. So what will happen here? This gate current is in minimum position, means at 0 only. Now here increasing this value at G max minimum, then only it will conduct. So that is the case. So firing angle increases as the resistance R2 increases. So this is the case for R2. And next, what about this R? This is R is a stabilizing resistance. Stabilizing resistance means the voltage across R, should not exceed the minimum gate voltage. Otherwise, the thyristor will be turned on directly. Okay, this resistance ensures that minimum gate voltage across the SCR is applied across the SCR. So now here, what about the diode? So this diode will protect gate drive circuit. So this diode will protect gate drive circuit from the reverse gate voltage during negative off cycle. During negative off cycle, this diode protects from the gate drive. So gate drive from the reverse gate voltage during the negative half cycle of the input. So this diode in the gate circuit prevents the reverse voltage of the thyristor during negative half cycle of the exceeding peak reverse voltage. And next here, this R firing circuit is the simplest and economical type of triggering, but it is limited to few applications. It is limited to few applications means this alpha value is less than 90 only. So up to is limited to up to 90 degrees only, because applied voltage is maximum at 90 degrees. So the gate current has reached maximum gate current value somewhere between 0 to 90 degrees only. This is the case for R firing circuit. And next, RC circuit for half wave rectifier. So now here in this the limitation. So R firing limitation can be overcome. That is up to 0 to 90 degrees only. That can be overcome by RC triggering circuit, which provides the firing angle control from 0 to 180 degrees. This is the case for 0 to 90, and this is for R, this is for the RC. By changing the phase and amplitude of gate current, a large variation of firing angle is obtained by using this circuit. So now let us how it will be control the firing angle control from 0 to 180. So first here, by varying variable resistance, here this is variable resistance, the triggering or firing control is controlled in full positive half cycle signal, so that we will see. So now here during negative half cycle. So first during negative half cycle, negative, positive. So here during negative half cycle, diode D1 and D2 is in forward bias, and this capacitor charges. This capacitor charges. So minus plus, and next here with lower plate positive through D2. This is through D2. So it will not go to this route. So it will this current path selects the least resistance path. Diode is in forward bias. It is a short circuit. So current flows in this. So this is the negative. So now this is a V0 and this is a VT. So now here, so this anode, this is the cathode, and this is the gate. So now here the capacitor will charges with lower plate positive through the diode D2 to its maximum voltage. And next here the voltage at negative maximum across the capacitor voltage till the supply voltage attains 0 crossing, then D2 gets reverse biased. So this D2 gets reverse biased when, so here this is the negative half cycle. So let us see here. So this one, so this is the negative half cycle. So in the negative half cycle, so now here in the negative, this is the supply voltage at this maximum voltage. This is supply voltage during negative half cycle. At the maximum negative voltage crosses capacitors till supply voltage at a 0 crossing, this diode D2 will gets reverse biased, and this C discharges through this R2 instead of D2. So now this capacitor voltage is here. So now here during positive half cycle of the input, so the SCR becomes in forward bias. So now here anode, cathode, and plus and minus, and next this is a gate. This is in forward bias. So now capacitor charging through the variable resistance. Now here this is plus and minus. So now here capacitor is charging through here this one. So now here through resistance the triggering value of the SCR. Initially it was here, this is the negative. This is a capacitor voltage and it is charging through this one. So when gate this capacitor voltage reaches to here, when capacitor charging voltage is equals to gate triggering voltage. So now here this is plus and minus, and next here this minimum gate current, gate trigger voltage, the SCR is in on, and the capacitor holds a small voltage, and therefore the capacitor voltage is helpful for triggering the SCR after 90 degrees also, greater than 90 degrees also, means this triggering angle 0 to alpha to 180 degrees. Now what about this D1? So this D1 prevents the negative voltage between gate and cathode during negative off cycle of the diode D2 through D2. And next here the waveforms are here. This is the supply voltage, positive and negative, and capacitor voltage is here, it comes here and it comes. This is the gate voltage VG. And now here RC firing circuit for SCR. So now here RC firing circuit, here power is delivered to the load during positive and negative half cycles because of the full bridge. Here in the previous case in the negative cycle, so that is in here in the during positive and negative, both the cases, so power is delivered to the load. So now here the firing angle can be controlled from 0 to 180 degrees. The power delivered to the load is doubled and the output voltage is present even negative off cycle only. And next here, so what I will do first here, so when this is positive off cycle and negative off cycle, in the during negative off cycle, so now here current flows, this is negative and this one, and this is negative, means here this is the case for this is anode and this one is a cathode. So during positive off, this is a negative, and during positive off cycle I will take first. Now here, so in this case, so here this is the case, so this plus is for, this is anode and this is for cathode. So now here this is the case for, now here current flows through this one. So now here capacitor charges. Okay, so now here when when capacitor achieves the sufficient voltage to trigger this gate voltage, and then this SCR will be in SCR will be from forward blocking mode to the forward conducting mode. So now here what I will do, now here during negative off cycle minus and plus. So now here this is minus, means here this one, and this is plus, means here minus. Previous one is the plus. And during negative off cycle here, so this is the case, in this case also, when this capacitor charges and when it will reaches to when this value is equals to this gate triggering voltage, so its value is, it will be gate is turned on and then SCR will be is turned on position. So now here, now UJT firing circuit, same as, so here the circuit diagram is, it looks like this. So now here, so this is the UJT B1, this is B2 and this is the emitter. So B1, B2 and this is the emitter, 3 terminals. So here main advantage of firing circuit. UJT firing circuit means, so R firing circuit can be in the alpha value 0 to alpha to 90 only. In the RC, alpha to 180 degree, 0 to 180 degree alpha value. In the UJT also, that alpha value 0, alpha and 180, and main thing is there is a isolation between gate drive circuit and supply. So electrical isolation is compulsory. So now here isolation, this is the most important isolation part. So here this UJT firing circuit provides the electrical isolation for the gate. There is a pulse transformer. So this is given to the gate and cathode of the SCR. So now it is given to the gate and cathode of the SCR. So now here same operation here, when it is, this is a Zener diode, it maintains constant voltage. And now here if you give the during positive off cycle means this is anode, and next here it is connected to, and it charges. And now here it charges means here when capacitor voltage attains some value. So now here when capacitor is charging, so now here this is having peak value and valley value VV. So when capacitor voltage is exceeds VP value, this UJT is turned on. And this UJT is turned on means here that is given to the pulse transform. There is a isolation. This is a pulse. It will provide the isolation between supply and gate cathode voltage. Same way here, when it will be turned off here, so that capacitor voltage, it will be discharges later, and when capacitor voltage less than this valley voltage, and then it will be turned off and this gate will be disconnected from the SCR. Same fashion for negative off cycle also, these 3 diodes are conducted, same fashion will repeat. In this way UJT firing circuit will works. So now here we have studied R triggering, RC triggering and UJT triggering. So in this mainly this point 0 to 90 degrees, and here in the RC 0 to 180 degrees alpha value, in the UJT triggering alpha 0 to 180 degrees. But here one extra feature for UJT firing circuit is here electrical isolation between gate cathode and gate cathode terminals and supply. I hope all these firing circuits are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.